Hello everyone, today we're going to talk about a very interesting problem which is find the minimum in the rotated sorted array. So the people who don't know what is meant by rotated sorted array, let me explain to you guys. Basically it's very simple. Let's take a sorted array 1, 2, 3, 4, 5, and what do I mean by rotation is, let's take, I'm doing rotation 1 rotation. At the first rotation I will pick the first element and put it at the last. I'm just rotating it, right? It is in a sorted format. I'm just picking an element, I'm just rotating it. Now if you see the array, it will look like 2, 3, 4, 5, 1. And if I do one more rotation, it will look like 3, 4, 5, 1 and 2. That's what I mean by rotated sorted array. And I think some people would have guessed by the word sorted array. So whenever you find the word sorted in a question, obviously we're going to apply binary search for this problem. Yeah, that's right. And today we're going to talk about the binary search solution for this. Without wasting much time, let's get into the problem. And before moving to the optimal solution, let me talk about brute force like very quickly. I think brute force is very simple. You can just do a linear search and find the minimum element. And that is not acceptable, right? The linear solution will take O of n time. That's not acceptable. Even though it's optimized like O of n, still we can do better with binary search solution. We can do it in log n time, which is obviously better than O of n. So now let's see how we can perform log n time and find the solution for it. So if you look at the binary search template, it's a constructive algorithm. So we need to follow some pattern. If you see in the binary search, we have something called left half, right half, and we have something called mid. And with the mid, we have something to compare with it. So depending upon the this result, we'll just eliminate the half. And right now, do we have anything to compare with the mid? Just think, guys, do you have anything to compare with the mid, like something kind of target? No. So we don't know like which is the minimum element. So we need to find that only. So do we have any kind of target here? If you look carefully, yeah, we do. We do have something to compare with it, so, which is okay. Let me take some random element from this particular array. Let me take out 7. So what is the magical thing about sorted array is, if you look at in a sorted array, if you look at right side, I mean left side of the element, it would be lesser. And if you look at the right side of the element, it would be greater. Am I right? Or that's a beauty of a sorted array. If you can pick any element, I can pick 8. If you see left of the 8, it will be lesser. Am I right? Left of the 8 is lesser. But if you look at right side of the 8, it is greater. That's the point of having a sorted numbers. But for our given question, there is one exception case, which is our answer. If you look at an answer, which is 1, right? This is a minimum element, a given element. So we need to return 1 as an answer. But if you pick the 1 and if you look at the right and left, both the values are greater. That's the beauty, right? You can find the both the values are greater. So this is the one exceptional case. Now we build the intuition for the target. So what is the target is looking for an element which is less than the both the neighbors. So we are looking for an element where both the neighbors are greater than it. That's what our target is. Now we need to identify left and right region and which we need to eliminate it. This is the tricky part, because if it is a normal sorted array, we can simply eliminate. We know if a target is lies on this position, we can simply eliminate this part. But right now it is rotated. So how do you build the intuition for identifying which part need to be eliminated? So now let's look into it very detailedly. Now tell me guys, which part of this array is sorted, either left or right? If you guess left part is sorted, then that's well and good. And for people who don't know like how to find which position is sorted, it's very simple. What you have to do is compare the values with the mid element. So if you want to tell the left region is sorted, we can simply compare mid value must be greater than the left value. If this condition pass, we can tell the left region of the mid element is sorted element. Again, how can I tell this part is sorted is simple. We can check the right or high. You can have anything instead of L and R. I can have L, low pointer, high pointer. We can simply tell high must be greater than the mid element. If this condition pass, I can tell that this part of right region is sorted element. Now if you apply this particular example formula, you can tell me that simply this particular region is sorted because 15 is obviously greater than 5, which indicate that this region is sorted, whereas this region is not sorted, because in this we consider high must be greater than the mid. If you look at high is 4 and the mid element is 15, does this condition pass? No, it doesn't. So what I'm telling that this particular region is not sorted. And if you remember carefully, so answer never lies on the sorted region. Answer never lies on a sorted region. So what we can do is we can simply move the sorted region, and I mean you have to move index plus 1. This is a typical binary search template. We have to do left, always low is going to be mid plus 1. So we'll move this pointer here. Again we'll do the same operation again and again until unless we find the answer. So now let's apply this concept. Now we found out that this particular region is sorted and answer won't lies on this place. So what you can do is you can just take this pointer and move to this particular index. Now it will look like this, and now let's find the new midpoint. Our new midpoint is going to be 2. Now just compare mid element with left. Does it greater than? No, it doesn't greater. So left region is not sorted. Now just compare with this right element, I mean the high position. Whether 4 is greater than 2, yeah, it's correct, which indicate this right region is sorted. So what you can do is we can simply move the high pointer to this particular place. Now let's find the new mid. Our new mid is going to be 1 itself. Now just compare left and right element. Does this satisfy this condition? Yeah, it does. Now you can confidently tell that 1 is going to be the minimum value in a given array, so that we can directly return 1 as an answer. And I hope you guys understand the approach. So now let's write the pseudocode for this. And let's talk about the base cases. There are two base cases. One is going to be what if there is array has only one single element? There is one base case, and another base case is going to be, so what if the given array is already sorted? So we need to take care of this both the thing, right? So now let's write the code for this first, and then we'll write the binary search solution for it. And you'll be surprised, it's going to be similar template for binary search. So now let's write the base cases. First base is going to be only one element. So what if what if the array is only one element? If the size of the array is going to be 1, so we can directly return the 0th element as the lowest one. If the size nums of size is going to be equal to 1, so we can directly return that the 0th element is going to be largest one. And now let's talk about the second base case, which is going to be what is a given element is already sorted. So before that, let's declare the left and right pointers, guys. So left is, as always, left is going to be at the 0th position, and right is going to be n-1. So when does this happens is, like, we can simply write if case. If nums of left is less than the right, we can tell that given input is already sorted. Let's take an example and see, guys. And left is there, right is here. And if you apply the condition, it will get passed because 5 is greater than 1. And if you look at the array also, it's already given in a sorted format. So we can simply tell that the given array is already sorted. And if I take a rotated array, let me rotate this. And if you rotate it to look like this, now this is going to be left, this is going to be right. Now this condition doesn't works, right? So left is going to be 3, thus 3 is less than 2. No, it doesn't. So which indicate there is some modification in the given array. So, and then we can follow up our logic. So when this condition pass, we can simply tell the given element is already in a sorted format. So just return the 0th element. Return nums of low or 0. I mean low in the sense left, because left is pointing to 0, or you can directly return 0th also. And now let's apply the main binary search solution. So we'll start with typical binary search while left is less than right, and we'll find the mid element. Mid is going to be left plus right divided by 2. And we'll check the if condition. As we discussed here, we need to find which position is sorted. Right, for that we have two different formula, which is mid is greater than left if I is greater than right. Now let's apply this here. Now we need to check if the mid element is greater than the right. If this happens, what it indicates is we need to search in the right position. So left is going to be mid plus 1, else we can simply move the right pointers. Right is going to be mid. After the while loop ends, we can simply return the left value, which will always indicate the lowest pointer. And there is a lot of concept in a binary search: lower polarity, higher polarity. And that's why the given question is lower polarity, which means we need to return the minimum value. For that, we can simply return nums of left. And if the given question has the maximum value, we need to return the high position that has the maximum polarity. There is concept like low polarity, high polarity. For the given position, it's low polarity, so we'll return left nums of left. And now let's pick one small example and go through this algorithm. Now let's check this example and apply this logic, guys. Now, if we take left is going to be here, right is going to be here, and midpoint is going to be here. Now we'll check this condition. If mid is greater than the right, yeah, it does, which indicates that this part of region is already sorted. You can see this is already sorted, where this is not sorted, right? So what we have to do is simply move the left pointer. We discussed in dry run also. So we just simply move this to this particular place, and now we'll compute the new mid. So what is the new mid right now? This is the new mid. And again, we'll check the condition. If mid is greater than the right, does it greater? No, it doesn't. So at that particular time, what we have to do is we have to move right point to the mid position. Now let's move this. Now, if you compute the new mid, it will lies at this particular position. Now tell me, mid is greater than or equal, mid is greater than the right position. Does it greater? No, it doesn't. So what we can do is we can simply move the right pointer to the mid position. This will look like this. And at this point of time, we'll exit the while loop and we'll return the left pointer. So left is indicating at the -1, and our result is also -1. And we'll simply return nums of left, and which will give our answer. And that's it, guys. And now let's code this up. I hope you understand this problem. Now let's start with the base case, guys. We discussed what if there is only one element in a given array. For that, we said that we can directly return the 0th element, right? So we can directly return 0th element. And then now let's declare the left and right pointer. So left and right is going to be 0. One will be at the starting, one will be at the ending. And now we have to take care of base case 2, which is what if the given array is already sorted. So we need to take care of that also, right? For that, we have to check if nums of left is less than nums of right. If it does, then the given array is already sorted. We can simply return nums of left, or we can return nums of 0 also. This indicate like no rotation. Now we need to apply the typical binary search template. It's very simple. So while left is less than right, and the mid position is going to be left plus right divided by 2. And the first case, if nums of mid is greater than nums of right, which indicate that the left position is sorted and we need to look for the right position. So we need to move the left pointer to mid plus 1. If not, we can simply move the right pointer to the mid place. At last, you can simply return nums of left. Now let's run this and see. This is typically the binary search, right? And you can see it pass all the test cases. There is slight modification in it. And as I discussed, there is a lot of things in binary search like low polarity, high polarity sums, and there are a lot of different patterns there. This is one of the pattern. So basic patterns. And yeah, now let's submit this and see whether it's passing or not. Yeah, it passed all the test cases. I hope you guys understand this problem very much, and I explained as simple as possible. So we'll meet again in one more video. Until then, keep watching, keep practicing. Bye.